In the previous video, we explained how to assign your machine configuration, also known as the file type, to your VMID. If that step wasn't completed, you need to manually ensure the correct configuration is selected. To do that, go to the Editor tab and choose the desired file type. Then, click on Backplot and confirm that both the control and machine are properly selected. Now, select Machine Simulation. Let's now go over the main functions available in the simulation interface. Click on Toolpath. A drop-down menu will appear, allowing you to show or hide the toolpath. You can also highlight specific toolpath elements like points and arcs. In this case, I will uncheck Hide Toolpath. The next function is Mode, which lets you choose how much of the toolpath is displayed during simulation. I'll keep Show to End to display the remaining toolpath. Now let's look at a key setting, Stop Conditions. Here you define which events will pause the simulation. The first option allows you to stop at every tool change. We can also set which type of collisions we want to make our simulation stop. Wrap to Stock. This stops when the tool cuts material during a rapid move. Stop the spindle cuts. Stops if cutting occurs while the spindle is stopped. Holder to stock. Detects collisions between the holder and the stock. And tools and models. Stops the simulation if the tool collides with any model, can be your target, fixture, or machine. In this last group, we can stop the simulation if axis travel limits are exceeded or when M0, M01, M02, or M30 codes are detected. Now let's open the tool setup. Here you see all tools exported from SolidCAM. You can view them as complete assemblies or switch to the cutter and holder tabs to see individual components. You can now close the tool setup window. Next, at the bottom right corner of the interface, click on the Simulation tab. Let's explore the key functions that help you fine-tune your simulation. Tool Workpiece Collisions. This option lets you choose when to detect collisions, during rapid moves, cutting moves, or not at all. Disabling it can speed up the simulation, especially when using Stock Compare for final verification. Cutter Allowance sets how deep the cutter can enter the workpiece before triggering a collision. This helps avoid false alerts from small model deviations. Hidden Model Collisions determines whether collisions with hidden models are detected. Keeping this on ensures full safety. Rapid Collisions enables collision checks during fast tool movements. Stop the spindle defines how the simulation reacts when the spindle isn't turning. Cut, don't cut, or mark the cut in red. Tool colors applies different colors to machine areas based on the tool used. And subprogram folder allows you to specify a custom location for subprogram files. If not specified, the simulation will look for them in the same folder as the main programs. Now, let's move to the Variables tab. Here you can monitor the current values of all variables used in the G code. As you move through the code, the values update in real time. You can also filter to show only the variables used in the current program. Next, go to Geometry Manager tab. Work Origin. This is the reference point for positioning all models from SolidCAM. If you change it, all geometry and toolpaths are translated accordingly. Work Offsets shows all imported work offsets and their current values relative to the work origin. Below that, you see the machine components. You can right-click to hide the entire component or expand the structure to hide individual subcomponents. You also find fixture, workpiece, and stock. These can be shown or hidden the same way. For these modules, you can also reposition them by selecting and adjusting their subcomponents. For the stock, there are two additional features. Click its icon to open a slider that adjusts the display quality of the stock model. Right-click to access the cross-section tool. You can fix the section to a defined plane and apply an offset, or use the gnomon to move it freely. You can also activate a dynamic cross-section, which locks the cutting plane to the tool's position. That concludes the main features of the simulation interface. In the next video, we'll explore how to simulate and analyze your results. Thank you.